Welcome to the Society of Amateur Radio Astronomers. This is Radio Astronomy, Constant Variables and Formulas. Lesson 13, Radiometer Equation Basics. The radiometer equation. For a target to be detectable, its signal must exceed the root mean squared fluctuations in the receiver. This is expressed as delta T cis. The radiometer equation is delta T cis is equal to T cis, which is the noise temperature, divided by the square root of eta P, which is the number of polarizations, T, which is the integration time, and delta F, which is the bandwidth in hertz. The big picture. The lower the delta T cis, the better your telescope is in detecting astronomical objects. To improve delta T cis, you can lower system temperature, you can add another polarization change, which is eta P from 1 to 2 polarizations. You can increase the integration time, and you can increase the bandwidth. Let's do an example. Measure T cis equals 70 degrees Kelvin. One polarization, integration time of 100 seconds, and the bandwidth is 1 megahertz, which is 1 times 10 to the 6th per second. What is your current delta T cis? If you put all those numbers in, it's equal to 0.007 Kelvin. If you decide to increase the integration time to 200 seconds, what does that do? You put those numbers back in, your new delta T cis is 0.005 Kelvin. Since this decreased the delta T cis, your radio telescope is more sensitive to lower signals. Example 2. Start again with the same values with T cis equals 70, 1 polarization, 100 seconds integration, and 1 megahertz bandwidth. You now make an improvement on your radio telescope. Your T cis is 80 Kelvin. Was your new T cis, delta T cis, and is this an improvement? So we go back and the original values, we get 0.007 Kelvin. Now after the improvement, we put the T cis is now 80 Kelvin, and we get 0.008 Kelvin. This is not an improvement because your delta T cis went up. If you like this video, like and subscribe. Join SARA to start your hobby of amateur radio astronomy. Go to www.radio-astronomy.org to join. Thank you very much.